Welcome to 10.7. In this section, we're going to be talking about areas of circles and sectors. The formula we're going to be using comes from theorem 10.11. To find the area of a circle, we take the product of pi and the square of its radius. So we're going to use area equals pi r squared. In this first example, we've got a bullseye dartboard here on the right, and the radius of the bullseye part, so this part right here, is 4 inches. And each additional ring is another 4 inches. So there's another 4, and here's another 4. Now they just want the area of the shaded region in here. So what we can do is we can take the area of this circle right here. It has a radius of 2 4s, or 8. So if I take the area, it is pi times my radius squared. 8 squared is 64, so the area is 64 pi. And what I can do is I can subtract from that the area of this smaller circle that has a radius of 4. So the area of that one, pi times my radius squared. 4 squared is 16. So now if I subtract that away, 64 pi minus 16 pi, I subtract the numbers. 64 minus 16 gets me 48, and I still have pi. So my area would be 48 pi square inches. So that would be our answer if they wanted us to leave pi in it. Otherwise, we could type that in to our calculators and we would get about 150.8 square inches. So it depends on how they want it. If they want you to leave pi in it, we would give an answer like this, 48 pi square inches. If they don't want you to leave it in terms of pi, we can type it in our calculator and get something like 150.8 square inches. We will be using the area of a circle formula to find an area of a sector of a circle. To find the area of a sector of a circle, we take the ratio of the measure of the arc over 360 times the area of the circle as a whole. So what we're going to do is find that measure of the whole angle, divide it by 360, multiply it by the whole area of the circle. So in this particular case, in part A, in problem 2, find the area of each shaded sector of the circle. We've got an angle here, measure of the arc is 36, so I would take 36 over 360 times pi times my radius squared. If I type that into my calculator, I get that the area of that little sector is 11.3. For this second example, I've got a 45-degree angle here and a 90-degree angle here, giving me a total of 135 degrees. So I'll put that over 360. I'm going to multiply that by pi times my radius of 2 squared. And when I type that into my calculator, I get an area of 4.7. Next thing we're going to be talking about is area of a segment. Now the segment, as you can see in this far right circle, is just this area right here. And that's what we're going to be finding next. And the way we do that is we can take the area of a sector, which is what we just talked about, and subtract away the area of the triangle. Now we talked about finding area of a triangle in the last few sections, so we're going to bring back those formulas. So when we do that subtraction, we're going to get the area of the segment that we are looking for. So in example A, we're finding the area of that segment. So if I find the area of the sector as a whole, I would take the degree measure of 90 over 360 and multiply it by pi times my radius squared. And that will get me an area of about 7.07. Next thing I'm going to do is find the area of this triangle right here. Now this is a right triangle, so the area of the triangle is 1/2 base times height. I know that this is my base and height because those are both radius of my circles, and if my one radius is 3, then the other one is as well. So if I type that in, 1/2 times 3 times 3, I should get 4.5. So the final thing I need to do to find the area of my segment, I take the area of the sector minus the area of the triangle, and I get 2.57. So go ahead and give the second one a shot. Pause the video when you're working on it, and then when you're ready to go ahead and hit play and see how you did. So as you can see here, in red we found the area of the whole sector. Now we did 90 over 360 times pi times our radius of 10 squared, and we got 78.5. Then from there we found the area of the triangle. Two radiuses are 10, those are our base and our height. So 1/2 times our base times our height would get us 50. And then finally, to find the area at the end, we subtract those two, giving us an area of 28.5 square centimeters. These next two are not going to have right triangles in it, so we're going to have to use a different formula than the one we did before. But to start out with, we're going to find that area of a sector the same way we did before. That angle over 360 times pi times our radius of 5 squared. And when we type that in, that gets us 13.1. Then from there, finding the area of this triangle. And if you remember the formula for the triangle, we can use 1/2 times side length A times side length B times the sine of the angle in between. And if we type that in, we get an area of about 10.8. And then the last thing we need to do, area of the sector minus area of the triangle will give us the area of the segment. In this case, it's 2.3. Just like before, give this second one a shot, pause the video while you're working, and then go ahead and hit play when you're ready to go. So, as you can see from my work here, the red is the area of the sector. I took the degree measure over 360 times pi times my radius of 2 squared, giving me an area of 4.2. The blue is my area of the triangle, 1/2 times the two legs times the sine of the angle in between, giving me an area of 1.7. And finally in green, the red minus the blue to find the area of my segment, 4.2 minus 1.7, gives me an area of 2.5 square meters. This last example is a little bit different. So now we're going to find the area of the shaded region, which is everything except for this segment right here. So we're going to do the same thing because I want to find the area of the segment. So if I take the area of the sector, it's a 90-degree angle, so it'll be 90 over 360 times pi times my radius squared. And when I type that in, I get an area of 113.1. The area of my triangle, 90-degree angle, so I can do 1/2 base times height, 1/2 my base times my height, both of those will be 12, and when I type that in, I get an area of 72. So now, when I go to subtract these to find the area of the segment, I get that my segment has an area of 41.1. And what I'm going to do with that, I have to find the area of the whole circle and then subtract that segment. Well, area of a circle, pi r squared. So pi times 12 squared. If I type that in, I get an area of 452.4. And so when I find that, I subtract the 41.1 from that, and I get an answer of 411.3 square centimeters.